Welcome to Section 5, Monitoring the Application Behavior with Prometheus and Grafana. In this last section, we will configure Prometheus to pull metrics from our application running on production. We will then configure Grafana to display data stored in Prometheus and create dashboards to visualize those metrics so that we can effectively monitor the overall health of the production cluster and application. In this video, we will learn how to configure Prometheus to pull data from the production environment. First, we will see what metrics we already have available within Prometheus. And finally, we will configure the ones we need to be able to effectively observe our application. If you recall from previous videos, we already created the Prometheus instance. We can go to the Google Compute Engine VM section to get the IP address of the Prometheus instance. Let's just do that. Once you copied the IP address, you can access the web interface via port 9090. By default, Prometheus ships with many metrics. As you can see from the select box, there are many metrics available in there. We won't be using all of them, but only the ones we need to monitor our application. The way Prometheus works is by specifying so-called scrape configs, which Prometheus can pull data from. There are many types of scrape configs, and they serve different purposes depending on what and how you want to monitor compute assets. The one we will use here is the Kubernetes SD config. The Kubernetes SD config is a functionality natively built in Prometheus that allows you to retrieve and discover metrics about your Kubernetes cluster. There are different sets or groups of metrics for Kubernetes available under the Kubernetes SD config. It is possible to get information about the cluster nodes, the pods, and the services running in the cluster. In our code editor, we are now going to create the Prometheus configuration file. Let's create a file called prometheus.yaml. This file will contain the configuration for Prometheus. I have already prepared a configuration file to use in this course for demonstration purposes. I am now going to paste its content in it, and then I will go through the various configuration parameters with you. With the configuration content in place, I will start from the top to explain the meaning of the various configuration fields. The global section refers to the whole of Prometheus server. Parameters defined in here apply to the rest of the inner configuration areas. You can see that we are specifying a scrape interval and evaluation interval of 15 seconds. That means Prometheus will try to pull data from its targets and evaluate the scrape rules every 15 seconds. Then we have the scrape configs section. This is where the various types of scrape configurations are specified. You can see it's a list. Every list item starts with a job name. The job name will then be available within Prometheus for querying and filtering. The first scrape config we have refers to the Prometheus server itself. You can see it's a scrape config of type static config. This type of scrape config accepts a list of statically defined targets. You can see the target of the Prometheus job is localhost. That is saying that we will be able to monitor and observe the Prometheus server itself. The rest of the items are related to Kubernetes. I will not go through them all, but you will be able to see we are going to try and observe several aspects of the cluster. For example, we are going to retrieve data about the API servers as defined in the second job list item. Then we have a job which will fetch information about pods, another job which will fetch information about the services running in the cluster, then another one for the nodes of the cluster, etc. There is a so-called role type specified underneath each Kubernetes SD config section. That role defines the type of metric groups or sets, if you may, to scrape. In the Kubernetes SD configs, you will notice there is a field named API server where the value contains API_server_IP wrapped in two sets of parentheses. That's done on purpose. We will replace this value with a real one shortly. The API server field is required by Prometheus to know where to retrieve the metrics from. The Kubernetes master nodes use several ways of authentication, and in this course we will use the HTTP basic authentication method. You can see there are two fields for that, username and password, and both of them contains placeholder values for now. Now let's go and replace the placeholder values. We will get the real values from the GCP console. From the GCP console, navigate to the Kubernetes cluster details page. You can copy and paste the endpoint IP address and paste it where the API_server_IP placeholder is set. Remember to remove the two pair of parentheses. Also, please note the API_server_IP placeholder variable is also set elsewhere in the configuration. I recommend you do a search and replace of the entire placeholder variable tokens. After entering the API server IP, then click on Show Credentials next to the endpoint IP. From the dialog window, copy the username and password of the master. Then paste them in replacement of the admin and password placeholder tokens in the Prometheus YAML config file respectively. After the Prometheus YAML configuration file is ready, we can upload it to the Prometheus server. From the GCP console, let's go to the VMs page. Then find the Prometheus VM and click on the SSH button. A pop-up window should appear and Google should let you log into the VM where Prometheus is running. As part of this video, I have already prepared an SSH session open. From the SSH terminal browser window, click on the gear icon from the top right corner, then click on Upload File and then select the Prometheus YAML file we configured earlier. The file will be uploaded to your system user's home folder. Let's now copy the uploaded file from that location to where Prometheus is installed. With the configuration file copied, let's now reload the Prometheus server. What we need to do now is to fetch the process ID of Prometheus. With the process ID of Prometheus, let's now send a reload command to it. With Prometheus reloaded, let's head to the Prometheus web page to see whether the server was able to now scrape information from the Kubernetes cluster. From the Prometheus web UI, let's go to Status and then Targets. Now we need to reload Prometheus. Let's fetch the process ID. With the process ID copied, let's now send the reload signal to it. With the configuration reloaded, let's head to the Prometheus web page to see whether Prometheus was able to scrape information from the Kubernetes cluster. From the Prometheus web page, let's click on Status and then Targets. As you can see, Prometheus was now able to fetch the information from our Kubernetes cluster, but if you scroll down, you will notice that at some point the Kubernetes-pods and Kubernetes-service-endpoints reverse 0 to 0 up. That means that there is no information available at this moment for pods or services. That is expected. In order to get that kind of information, we need to adjust our Kubernetes resource definitions. What we need to do is to add an annotation which will allow Prometheus to scrape the pods and services information. From our code editor, let's open the myApplication YAML file. In the myApplication YAML file, let's add the annotation to the various resources. With the annotation in place, let's commit those changes. Now with the changes pushed, let's wait for the continuous deployment pipeline to do its job. The deployment is done, and it was successful. Let's now go back to Prometheus to see whether the pod information and the services information are available. As you can see, we already have the service endpoint information. After a while, we should soon see also the Kubernetes pods information.